we have to find the dimensions of a rectangle, and we have an area of land that's inscribed by x-axis and the y-axis, and the graph of y equals x8 minus x cubed. Okay, let's tackle this. We've got, so let me move this up a little bit here. So get out your protocol, turn it over, you should have two sides, and let's answer the questions that are asked of us. So first of all, what is the question we have to answer? Well, we have to find the dimensions of a rectangle with the largest area possible. So maybe we have a plot of land and we want to build a building on it. We want to make sure we maximize the land to its most potential. Now we are given that we're bounded by the x-axis and the y-axis and the graph 8 minus x cubed. So you can see for this I have a graph of this, and we can see that we're going to want to build some kind of rectangle within here. So something like this within this plot of land, okay? And we want to find the rectangle that is maximized. Now, when we do this, then we always are going to write an equation in a single variable, and the reason why, then we can take the derivative and set it equal to 0. So area of a rectangle. We know that area of a rectangle is length times width, or length times height, whatever you want to talk about. So for my rectangle, if you notice, the length here, or the base of the rectangle, is going to be x. Now, what is the height of the rectangle? Well, the height of the rectangle is determined by the function 8 minus x cubed. Okay, so if I were to define my variables, then x is going to be, we'll call it the base of the rectangle. And then the height of the rectangle will be 8 minus x cubed. So, to find area, we multiply base times height. So the area then is x times 8 minus x cubed. So if we were to expand that, we get 8x minus x to the fourth. Okay, well, let's take the derivative and set it equal to 0, and then we can find our critical points. So I'm going to expand my work area here. So the derivative then of area will be 8 minus 4x cubed. Let's set that equal to 0. So I subtract 8 from both sides, divide by -4, take the cubed root. So the cubed root of 2 will be the base of my rectangle. Fantastic. Now, we would always want to check to make sure that truly is a maxima and not a minima, and we know that we can do that by looking at a sign chart. So if you were to do a quick first derivative sign chart and test it out at the cubed root of 2, we would see, like, if we plugged 1 into the derivative, the value would come out positive, and if I plugged in 2, it's going to come out negative. So yes, I do have a maxima. So if that is the base, then the height is going to be, so the height will be 8 minus the cubed root of 2 cubed, which is 2. So 8 minus 2 is 6. Now 6 what? What were the units of this problem again? The units were, whoa, I don't know the units. So if units are not given, I do not have to express my answer in units. So height is 6. Whoops, I have to switch back to pen mode. Height is 6. And then the base is cubed root of 2. Okay, now let's verify, make sure that we've answered everything. Did we answer the question? Yes, we found the dimensions. Did you use the correct units? Units were not given. Is it in the domain? Yes, so if we plugged cubed root of 2 into the original function, it is within the domain. Wow, fantastic work. Now what you need to do is you should have both sides of the protocol filled out, and then access the Google form, and please put in your answers to the even questions in the Google form, and then answer the 2 reflective questions about how we go about using derivatives to optimize a problem.